So we have the absolute value. Anytime you have the absolute value, you know you're going to be looking for a v. So what makes this 0? Negative 2. So negative 2 plus 2 gives me 0. So negative 2 is there. If when I put it in, there's nothing added, so negative 2 gives me 0. So my y value is 0. So I have negative 2, 0. So you need to, so we're gonna put in negative 3, and we're also gonna put in negative 1. So negative 3 plus 2 is negative 1. Absolute value will give me a 1. So I have negative 3, 1, 2, 3, 1. So negative 1 should give me the same thing. 2 minus 1 gives me a 1. This is my function. My inverse, remember, is you just flip the numbers. So instead of negative 2, 0, it is 0, negative 2. Instead of negative 3, 1, it's
1, negative 3.
1, negative 3. Negative 1, 1 is 1, negative 1. So now we plot those points. Again, this is my function. How can I determine what my inverse should look like? Move that paper. It should look like this. So let's see if we're right. So we have 0, negative 2. 0, negative 2 right there. No, the inverse is still a v. It looks exactly the same. All it's doing is you're moving this like that. So it's literally going to look like this. So we have 0, negative 2. And then we have 1, negative 3. And then we have 1, negative 1. And we make our v. And we knew it was going to be on the side, and we knew it was going to look like that. All right. Exponential growth. Remember, to be an exponential function, you need your exponent, your variable, and your exponent. Growth. Would you have more if you go 5 times 5 times 5 and continue on? Or, because that's this one, or if I said 1/5 times 1/5 times 1/5. What would make it bigger and grow? A. So that's why it's exponential growth. Exponential decay would be the one that has the 1/5, because you're taking a fifth of it, a fifth of it, a fifth of it. So that would be a decay. Whenever you graph your exponential functions, I want you to put in these 3 numbers. The numbers are -1, 0, and 1. You have to determine, are you putting it in for your x's or your y's though? On this one, what is easier to put it in for, x or y? X. So for my x values, I'm putting in -1, 0, 1. So 3 to the -1. In your calculators, if you put 3 to the -1, you're going to get 1/3 or 0.33 repeating. So we have -1. If I put 0, 3 to the 0, anything to the 0 is always what? It's always 1 is right. And then 3 to the 1 gives me 3. I got to plot these points. -1 and then 0.3, so it's barely there. 0 is 1 and 1 is 3. This one is called an asymptote. It gets close to the x-axis, but it never crosses it, so it's going to just keep following the x-axis. This is going to shoot up and keep going up forever. 15. What numbers, first of all, am I putting in numbers for y or x? X. What three numbers am I putting in? Very good. -1, 0, and 1. In your calculators, go 1/3 raised to the -1. What do you get? Hopefully you get 3. 1/3 to the 0 gives me 1. And then 1/3 to the 1 gives me 1/3, 0.33 repeating is right. -1, 3. -1, 1, 2, 3 is there. 0, 1 is there. And then 1 and then 1/3 is right there. Hopefully this makes sense because this is a decay because it's 1/3. So it's starting big, but then decaying, but it can never get to 0, but it gets close to it. Logarithmics and exponential are what of each other? Inverses. Yep, inverses or opposites, inverses. Nope, that's not until the man. Inverse. Nope. There's got to be something you look forward to. Write in log form. Remember, it's always log. This is your base. This is where your answer goes. And this is where your exponents. Your base is below the line. So you have log base 8. So it's below that line. What? Answer. Answer, like 2. Answer, which is 2, because logs are exponents, which is 1/3. Rewrite them in exponential form. So remember that this is my base. Logs are what? Exponents. So logs are exponents. So this is my exponent. Exponent goes here. So it's a 1/4, or 1, sorry, why did I put 1/4? See how that's your exponent, Hannah? So this is your exponent spot. That's your base. Equals your answer 1/4. I'll do another one, so maybe that'll help you. Yep. Because you said it doesn't make sense, right? Is that what you said? Yeah. So logs, the base goes down here. So what's my base?
The
10. Your answer goes here. So what's your answer? 1. Logs are, which is your equals, logs are exponents. So what goes here? 0. It's just more practice. So this is your base. So it's 10. Logs are exponents, so that's my exponent. So a -2 equals my answer of 0.01. So it's basically being able to go back and forth to this. Logs are another name for exponents. Logs are exponents. To graph this, I have to get it in exponential form. What is my base? This is my base. So 6. Logs are exponents. So my exponent is y equals x. 6 to the y equals x. What are you going to put numbers in for? The x or the y? The y. What numbers are we putting in? -1, 0, 1 is right. 6 to the -1 is 1/6. You can put that in your calculator to find out. But 6 to the 0 is 1. 6 to the 1 is 6. Then we'd plot those. So we have 0.16 there, negative 1, 1, 0, and then 6, 1, 1, 2, 3, 4, 5, 6, 1. To prove something is an inverse, you're putting this in for your x value and you would solve it and you should get x. I'm going to just do, since I'm taping now, I guess I'll do two of the front just so you have it on the tape. The first step when you're finding an inverse is always switching x and y. So we have x equals 1 plus 2y. Second step is always to solve for your y. So I have to get rid of the 1 first, so I'm going to subtract 1. So I have x minus 1 is equal to 2y. And then divide by 2. So y equals x minus 1 all over 2. On h, when you have f of x equals 5x minus 7, first step is go y equals 5x minus 7. When you're finding an inverse, always switch x and y. So we have x equals 5y minus 7. And then we have to do what? You guys know? We have to solve for y. So I'm going to add 7. Divide by 5, so I have x plus 7 divided by 5 equals y. Last step is, what did we just find? We just found the inverse. So the other way we can write the inverse is f to the negative 1 of x is equal to x plus 7 over 5. Any other questions before I... Yep. All right. Not completely. So the first step when you're finding an inverse is always doing what? Switch x and y. So now it's, instead of x, it's y. X squared is equal to 10. What's your next step? What do we have to do next? Solve for y. So I need y by itself. So what is x squared doing to y? It's multiplying. It's right next to each other, so that means multiplying. So we're going to divide by x squared. So y equals 10 divided by x squared. And that's my answer.
Yeah, I got y